Hey guys, welcome to DevOps In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
Okay, so first question is, what is Docker? Okay, so typically when we say Docker is a container management tool. Container management tool. Okay, this is a container management. Now next question is, what is container? Before answering this, what is container, what is management, and understand this one, so I don't have to tell you, but MGMT. But what is tool? So tool which save cost, right, save time and improve efficiency, correct? This is the something which is done by tool. So basically through Docker probably you will be able to save cost, save time and improve efficiency, right? But for what? Right? For what? So running applications. Okay, so that is a requirement here, what we have here. So now this is the meaning of tool. So when you want to run application, you want to save cost, you want to save time. That means you want to reduce the runtime environment setup and stuff like that, and improve efficiencies and all stuff like that. So with that, what is a container? So basically container, when I say there's so many definitions which we have. So when we say container is a complete independent, that's a very important one, independent runtime for applications. Yes, it's an independent runtime without any additional dependency. So its container is a complete independent runtime for applications. But actually, what is a container? I must tell you. So understand this way. MS Paint. Let's understand this way. So here, this is the hardware layer. On top of that, we have operating system. Okay, now operating system has what? So applications runs with the help of operating system, correct? But operating system has what? We need to understand. Operating system has what? So operating system has few important component. One of the component which is called kernel, right? Now operating system has kernel, but what kernel has? Kernel has namespace. Kernel has C groups. Kernel has capability. So these are the things you have in kernel. So this is a namespace, C groups, capability. Now what you have in the namespace? You have user namespace, you have PMAP namespace, you have MNT namespace, you have user PMAP, MNT, and one more, network namespace. Okay, so network namespace. So these are the kernel. So now if you want to understand this, let's check it out one image here quickly. See here. See here. Okay, look at this here. So the one which I am needed right now is, look at this. Here I'm talking about, this is a MNT, this is the PID process map, this is a user, this is the network, this is the C groups. These are the type of Linux namespace. Okay, so what exactly these are? So this create user, okay, space, user space, the one you log in. So when you log in, let's say I've logged in as a Rajesh, so this is created by user namespace. Okay, now if you log in by using some other user2, then you will get this one also, one get initialized. So here, how many users you can create in one machine? Multiple. Okay, now what is a PMAP? So this is a PID, basically PID. Okay, so what is this PMAP? So process map, we call it process map. So process map is something like that. This one I'll show you. Let me close this. See here, you go see here, this is called process PID. See here, PID, we call it process map. Okay, so every process map start with 0 and followed by those process ID. So here in kernel we have a PID also. MNT, what is that? So MNT is like a root file system. When you want to see root file system, let's understand that. Root file system means, look at this image. See here, this is the root file system. See here. So whatever you see in operating system after logged in, this is the root file system. This is the root file system. Have you seen this in our operating system? Anyone? Have you seen this? Hello?
Yes, it's file system tree.
Yeah, file system tree. So this is a root file system, MNT. Okay, and after that, what is a network? Because of this you get a one network. So network. Now because of these namespaces you get operating system initialized. So basically how many users you can create? Multiple. How many process map you can have? One. Process map means one. How many mounts you can have it? Mount tree? One. How many network you can get it? One. Done 111, whereas user you can get multiple. So this is a namespace. Groups doing what? C group is allocating a CPU to PID. Okay, see here, let me show you. This is the PID PID 4, and you see that CPU is getting allocated. Who's allocating this? CPU, this one, C group. Okay, and capability is doing what? Assigning access to root, because there's a different kind of root, right? Root and non-root. So these are two kind of user, root or non-root. So accordingly they are root or non-root. So these are the things which we have in the kernel. Okay, understand that. So now I was talking about container, but here I started talking about the operating system. So actually the answer is hidden in this here only. Now the question is, what is container? Look at this here. This is the kernel, has a namespace. These are the namespace, C groups, capabilities. What happens actually, now I'll draw the picture. So when you say operating system, you have all this stuff. Okay, you have all this stuff. These are the stuff. So let me close this now. Okay, so here you have all this stuff. These are the stuff. Okay, so when you say this is the stuff, okay, in the kernel. So what happens on the top of the kernel? This is the kernel. Let's understand on top of hardware. Okay, so this is the kernel. This is the kernel. Now what happens on top of kernel? You get what? Multiple users. User 1, user 2, user 3. So like that you get a 3 users created. Now because of user space, this user got created. This user got created. 3 users. Here you see I said multiple, right? Multiple. So here this user got created. Now PID will be created again 1. So let me show you one picture here. So look at this. One process map will be created. This is the one process map that come from where? Here. Okay, this is one process map. Now and one MNT will be there. One MNT. So this is MNT. Okay, and this is a network. So here you see here all users see the same MNT. That means this picture is been shown by all users. Don't you think so? It's been here. This guy user 1 also, user 2 also, user 3, all they are able to see this mount. Okay, the network they will be able to use everyone same network, and they'll be able to see the process map also everyone. Understand that? So this is the typical operating system. Did you understand this?
Yes, yeah. So now when we log in user, we are able to see all of that. Yeah, you are right.
Right. So now what happens? The question was, what is container? What is container? So actually what is happening? Think about it. You running application Apache here. You're running Apache here. Apache here. Okay. So when you run Apache, then it's running on 80 port and it's writing in OPT Apache and it is running on 50 PID. Now, is there any chance we can run this Apache also by other user in 80 port? Can you run it? Can you run it?
No, no.
Because how many networks you have? One.
One.
Right? Can you write both the Apache on same mount? It can write, but the data integrity will be compromised, right? Because the data is from this Apache or this Apache, you don't know, right? So why? Because you are not able to mount it, because we have only one mount. OPT Apache is only one. Now what is the PID? 50 PID, will you be able to get it? No. Why? Because there's only one process map, only one process map. So because of that, you are not able to run 80 OPT Apache 50 PID, 80 OPG Apache 50 PID. Now you must be wondering why we are discussing here. So we are discussing here because we are using containers. Now why containers? Why containers? Because to come off the drawbacks of virtual machine, drawbacks of virtual machines, VMs. Okay, now let's look at the VM model also. See here, this is the hardware layer. This is the hardware layer, and top of that, this is the hardware layer. On top of that, you have a kernel. Okay, and top of the kernel, you have a hypervisor. And then we have a what? Virtual machines. This is the virtual machines. 1, 2, 3. Now this is the operating system. Again, you get in virtual machines. Correct? And then you have a user, and inside there you run Apache. Correct? Now this is something you do that. Correct? Right?
Yes, yep.
Yeah. So because of this, you see what is a waste. Here to run 3 application, you are running 4 operating system. This is the waste. That means operating system also consume CPU, RAM, storage, and licensing cost. So this is the problem here. So that's what we are trying to fix it. We want to save cost in terms of running application in data center, save time also, and improve efficiency. Okay. So now what do we want to do? So look at this, back to the same model here. What we want to do? So now if you run in the one operating system, here we had a 4 operating system because of virtualization. So if you want to run 3 Apache, can you run the Apache 3 Apache? Yes, you can run it. But what you have to do, you have to change the port 81, 82, 51, 52, OPT Apache 1, OPT Apache 2. You have to change the port and you can run this. You can change the PID, you can run it. You can change the path, you can run it. There's no problem. But if you change the port, do you think the load balancer will work? Load balancer works on what? Tell me. Load balancer will work on what concept?
It will work on a round robin or
No,
distributing the load
for
across
the
all
load
the.
balancer, what is the minimum requirement? Different IP address and same
Say
port, correct?
yes.
But here there is only one IP address, not a different, and different port, opposite. It's complete opposite. So load balancer will not work here. So you can run this application 3 Apache, you can run it. It will be cheaper. Only one operating system is there. It will be cheaper, but you cannot offer to the client. You cannot offer to the client. So now the question is, what is container? So here there is one guy, Solomon Hikes. Okay, Solomon Hikes. What he did, this guy. This guy, what he did, he said, let's do one thing, let's not disrupt the operating system, let it run as it is. But what I will do, on top of the operating system, okay, I will install one of the tool somewhere here on top of it. Okay, and this tool will be Docker. What this tool will do, this tool will create, will take, understand that this tool will take user and create one user. So let me clean some areas here. So what this will do, this will take user from here and create one user here. Okay, this will take PID and give one PID here. This will take MNT from the kernel, give one MNT here. This will take net from the kernel and will create here. And now this is a user, think about it. And here you got each, see here, this user is having shared MNT, PID and process map, but this got your own. Let's create one more user and give this own copy of MNT, PID and stuff like that. And who's managing this? Docker. Docker is taking from where? Kernel. So now this is basically container. Understand that. This is container. Understand, dude?
So can you explain one again? Means like it's we are not using a share concept here. We are creating a individual pointers
Yeah.
to the namespace rather than
Yeah.
sharing.
So what is a container? So container is user isolation. User isolation. See here. User, like a user 1, user 2, user 3. This is a user 4, user 4, 5. So user isolation. But with their own network, process map and mount. That means in a simple way, they will be having their own mount. Each user will have this mount. See, when I log in, I see desktop, correct? But when you log in inside a container, you see this one, each one of this. So how come? Because that will be done by Docker. Mount will be done by Docker. Understood this? So here, what is a container? So container is a user isolation namespace, okay, but with their own network, process map, mount. Who's managing this? By Docker. And Docker takes from where? Docker takes from kernel, and kernel has all the library anyways. They initialized n number of it. These are the nothing but a library. They initialized n number of times. Make sense? Got it? Hello. Hello, guys.
Yes, all isolation with all the remaining thing was this is Docker.
Yeah.
In short, yeah.
So
In short means like user plus all the resources
all
sharing
the
is
resources.
Docker.
In short, if you want to know the official definition, lightweight application runtime environment. That's all. Runtime independent environment. Okay. So this is the here. So the container is not having any operating system. Understand that. It has only this user PID network MNT, and this is what any applications needs it. Make sense?
So are they not copied, right? They are just pointing, right?
Copied means.
Means the libraries which are there in the kernel, are they copied
Mhm.
into that container or they are just pointers referring to the
No, no. What
namespace?
happens? These are the libraries. What happens? It's like this. Do you understand the concept of object from the classes?
I'm sorry, I'm not a programmer, but yeah,
Okay, no
but
problem.
that's
So
yeah.
here, let me show you here. Uh, Class object. Okay. So see here. You create a class. I'm just trying to help you to understand that concept. So this is the class. See, look at this here. There's a class called dog, and how many dog you can create? Dog 1, dog 2, dog 3, dog 4. Correct? You can create as many dog. Correct now?
Yes,
Correct? Yeah. So same way, see, if human is a class, how many human you can create? See, there's a student class. You can create Nancy, James, Gabby, and Goldie. So like that. So here also, this is something similar. These are the libraries, nothing but some properties are there. You can multiply it any number of times. But what has happened? What has happened? You operating system company like Microsoft and Windows, they applied only one, which is here 111, and multiple user was allowed to create. Why? Because what you will do is the multiple network, what you will do with the multiple mounts, what you will do with the multiple process map. But you can work multiple people in one machine. For that, they allowed you to create multiple user. So now what they're doing, this concept was PC concept, personal computing. So now what they're doing, they with the help of Docker is assigning this whole user space and recreating. And the only difference between this user and this user is having shared mount, PID, and MNT, but this user is having their own mount, PID, and MNT, but who's managed by Docker, not operating system. Make sense?
Rakesh, you are
yes.
able to hear me?
Yes, I can hear you.
Yeah, like in one physical machine, how many containers we can create?
Okay, so I will ask you in a simple, a different way. In a physical machine, how many users you can create? Tell me.
N number of users.
So n number of container, because I'm telling you, container is nothing but a user space. Here I also wrote no. See here,
Okay.
container is a user isolation namespace with but their own network, process map, and MNT. But who's doing this own? By Docker. Docker is taking from the kernel, which is already available in the kernel namespaces.
So
So it's you only.
Okay. So like
You are also container. I am also container, but there is a problem with me. I can have a network which is shared network with all the user. I can have a mount which is like C drive and D drive is shared with all the user. Process map which is shared with all the user. But these containers, these user space have their own dedicated one with the help of Docker.
okay. So like so at the same way, number of how many Docker images we can create in the physical machine? N number of.
Docker image you can create as many number of it as you want. I'm not talking
So
about the
based
Docker image. I'm not talking about the Docker image right now. I'm talking about what is container right now. Docker image I'll talk about a little bit later.
okay. So which we are creating in AWS VM. So that is nothing but one of the container, you can say like that.
What is that?
We create VM in AWS,
What is that?
correct? Virtual machine in AWS.
Mm-hmm.
So that
Yeah.
is nothing but container.
Yes. No.
Okay.
No. That's not container. That's not container. That's not container. So that's not container. Just give me 2 seconds. So virtual machine, that's whatever you create a EC2 instance, that's a virtual machines actually. But here what I'm saying, what is a container? Any idea? What is container?
User own space.
Yeah. So inside operating system you get it, right? You are also container. I am also container. I've logged in as a container right now. But the problem here is, that's what I'm telling you. Don't think container is something different. You are container, I am a container. But the problem with me and you is we are shared container. That means we get a common network, common mount, common process map. But these containers get their own independent one. That's the only difference what we have. Are you getting opens?
Yeah.
Guys, any questions now?
No, sir.
Okay. So now, guys, this is the container. It's a lightweight app runtime environment, complete independent environment. So yes, guys, what is a Docker then? It's a container management tool. Right now, it has a two different release. C stand for Community Edition, okay, and then E stand for Enterprise Edition. We are talking about the Community Edition only. Enterprise Edition not needed. Now, Community Edition is free. This is paid. Docker is written in Golang, okay, and again it's open source, okay, and freely available tool. Now one more thing here is, this is written by Solomon Hykes, which I showed you, that Solomon Hykes. Now this is written Golang, and first release has happened, I think, July 2014 or something, 14, okay, something like that. Okay, so this is a Docker. Did you understand this,
Yeah.
guys? Okay,
Yes,
so
yes.
now let's move on. Now let's talk about how to install Docker. Okay, so how to install Docker, and for that I am directly moving to the demo. So here let me create one EC2 instance. So here I'm creating one EC2 instance. Or is it? Just a second, guys. I think, did I made a mistake actually? Hold on a second. Wait a second. So guys, there is a one problem what I did, and the problem which I made it is, I got a one WhatsApp message just now, and sorry, the repeat session I was supposed to have 11 o'clock.
Yeah, correct. I
So
also
by me,
confused.
yeah, even I got confused. So I think 2-3 people have messaged me saying that they cannot attend because we planned for 11 o'clock. So can we do one thing, guys? Can we call it off and then do at 11 o'clock only? What do you say?
Yeah, sure, that's fine.
What? Everyone is okay for this? Everyone is okay for this?
Yes,
Yeah,
yes,
okay.
Raj. Yeah, that's
Yeah.
fine.
So, w-
I think for some of these people, they will be
so
having
which
problem.
days is our class?
So see here, this is the calendar. 7 this Tuesday, Thursday, Saturday, and Sunday. Now there's a 7 a.m. IST. All are in the IST format. Okay, so you can convert into your time zone also. How can you convert? There's a ways to Google Calendar. Click on this. You can convert into your time zone also. So here, okay, see here. Right now, this is the calendar right now. So you can convert in your time zone and add it in your time zone also. See, you can add it here. Okay. So by the way, so here 11 o'clock means 2.5 hours to go from now. Okay.
Okay,
So
yeah, that's fine.
yeah, what do you say, guys? Because there are few people who will be attending in the morning, so I think they will be missed. And again, I have to repeat this session.
No problem, Rajesh. That's fine.
Okay, guys. Yep. So let's connect at evening. It was just done by me, my mistake. I'll just correct this stuff. Sorry about that. Okay, guys. Bye, everyone.
Thanks for watching. To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.